All right, so a fair question to ask now would be, okay, we learned the equation for a plane. We can use it when we're given everything to start, but this finding a normal vector thing was supposed to be tricky, so how do we deal with that type of problem? Oh no, I'm on the eraser tool. So what if we don't know n? Kind of like, what if somebody asked you to solve an equation for a line, but they didn't give you the intercept or the slope? We're going to have to calculate it somehow. And vectors are tricky, and I'll just say that usually we're going to have to use the cross product to do this, because the cross product is sort of defined in terms of being perpendicular to things, being normal to things, so it makes a good source of a normal vector. There's a few different types of problems that can come out of this section. I'm going to show you one and then talk through the steps for the others, just because of the amount of time we have available for examples. And this example is going to be the one that follows the format of your second participation problem. So go ahead and draw a little star next to it in your notes. Make sure to follow these steps carefully, because it's what you'll be doing to kind of show that you watched these videos. And this example is going to be when we want to find the equation for a plane that contains 3 points. And those 3 points are going to be -1, 2, 1, 0, -3, 2, and 1, 1, -4. So if somebody gave you this problem, you would say right away, okay, it's a plane problem. I know I need a times x minus x0 plus b times y minus y0 plus c times c minus c0. And then you would say, somebody gave me lots of points, so I can at least fill in my x0. I'm going to use this point right here, but really you could use any of them. Minus 1 is +1. Got -2. I've got -1. But nobody gave me n. Nobody gave me what those quantities a, b, c should be that define my plane. And so to find that, I have to use these other 2 points somehow. And I want you to think about that problem we had in our review, where you were given 3 points on a triangle. I like that. P, Q, and R. And then you found out that if you made a vector along the sides of, sorry, Google wants me to learn things, vectors along the sides of the triangle, then if you took a cross product of those two sides, you got a vector that was perpendicular to your triangle or normal to it. And so this vector actually is going to form a normal vector for our plane. If we kind of say that the point P is -1, 2, 1, Q is 0, -3, 2, and R is 1, 1, -4. Again, it's just a property of cross products that if you take the cross product of two vectors, you get a new vector that's orthogonal, perpendicular, normal to both of those original vectors. So if you take a cross product of two things in your plane, that will give you n. It's just a thing to remember. And so for us, we can go ahead and find these two vectors. PQ is going to be 0 minus 1 is 1, -3 minus 2 is -5, 2 minus 1 is 1. And PR is going to be 1 minus 1 is 2, 1 minus 2 is -1, -4 minus 1 is -5. Hopefully that feels familiar to you from last week. And then our normal vector is going to be given by that cross product. And I'm going to go ahead and use the determinant version because that's easier for me. If you want to follow along with the formula, that's okay too. We'll get the same answer in the end. So 1 minus 5, 1, 2 minus 1 minus 5. I'm going to have I hat times 25 minus 1, so plus 1, minus j hat times minus 5 minus 2, plus k hat times minus 1 minus 10 plus 10. So that's going to be 26 I hat plus 7 j hat plus 9 k hat. If that determinant method was unfamiliar to you, go back and watch the review video where I recorded that, or just stick to the formula if that's what's more comfortable for you. But now I know n, so I can go ahead and say, okay, my normal vector is actually given by 26, 7, 9. So my equation for my plane is 26 times x minus x0, so plus 1, plus 7 times y minus y0, that's y minus 2, plus 9 times z minus z0, that was my z minus 1. And that right there is the equation for this plane. And if you follow through these same steps, you'll be able to do that problem for your participation in web work. I'm going to go ahead and talk through a couple other ways that you might need to find normal vectors. So if instead of being given 3 points, we were given 2 intersecting lines. Maybe like x minus 2 equals 3t, y plus 5 equals minus 2t, z plus 1 equals 4t, x plus 1 equals 2t, y equals minus t, z minus 16 equals 5t. So if we're given 2 intersecting lines and we want to find the plane that contains those lines, then sort of this is going to come down to a cross product again, but we're going to know that this vector 3 minus 2, 4, that gives the direction of this line, and 2 minus 1, 5 are in the plane. If we know the vectors are in the plane, we know their cross product is the normal vector. And so you go ahead and follow the same steps we did on the prior problem. You take that cross product to get your normal vector, and then to get your point that you know is in the plane, you could find any point that belongs on either of these lines. For example, 2 minus 5 minus 1, minus 1, 0, 16. Any of those points would work. And that's just a different way to communicate something about a plane so that you can solve a problem with it. We can even do kind of like the backwards scenario. Maybe if you were given 2 planes that intersect. Then use their normal vectors to find a vector in their intersection using cross products. And one of your last web works in this section will be to do just that. So we'll get to talk through it in class and kind of discuss the steps. But it's flipping in reverse this first problem I told you about.